Back to my channel, Predicting the Future. Today, we want to talk about projection matrix and the least square method for in linear algebra, and we will prepare that for a new series topics about regression analysis. So today is about the basics of linear regressions, and the first one we want to talk about is a theorem, a basic theorem, basically a pretty straightforward result. So if the theorem is about if A is m times n matrix with rank n, which means that the columns of A are independent, and then the A transpose A is invertible. The proof is very straightforward. Suppose X is a vector that satisfies the equation A transpose A times X equal to 0. If A transpose A is invertible, we want to prove that X is 0. And so by doing an inner product of AX, so that will be X transpose A transpose AX, which is the inner product of AX. For this to be 0, because A transpose A times X is 0, so we know that this one is actually 0. But this is actually an inner product of AX of itself. So that means that AX is equal to 0. But A has all the columns of A are independent columns. We know that the only X that makes AX equal to 0 is X equal to 0. So that proves that X equal to 0, which proves that A transpose A is invertible. Now we are ready to go through what we need to know. We'll see why we need to prove that A transpose A is invertible later. So the projection matrix and least square method. What we are facing here is that we want to trying to fit a straight line of sample data, which will minimize the errors of the response value y with the estimated the regression line. So suppose so we can basically simplify this. If you look at, so let's first look at this equations. So B0 and B1 are the parameters we want to estimate for the linear functions, and x1 to x4 is the predicted variables, and y1 to y4 is the response variables. I want to find the B0 and B1 so that this equation has a solution. In most cases, doesn't have a solution. So instead of finding a solution of this series of equations, we want to find a B0 and B1 such that the xb, which is the xb, is close as close as possible. The value of xb is as close as possible to y. So that is, we are trying to find. We are trying to minimize the norm of y minus xb. We're trying to find a vector b such that y minus xb is minimized. And to do that, if we try to, so let's try to interpret this into in terms of vectors and linear algebra. So the projected vector of B, so x is so the columns of x basically is a space, which is the basics of linear algebra, and B is a vector that may not be on the column space of x. And so the closest point, the closest distance from vector B to the hyperplane of x is is the projection. It's actually the projection directly onto the plane, which is the closest distance of the vector b to the hyperplane x, which means that y minus xb is the vector from the plane to the vector b, the point on vector b. So this distance, we want to minimize this distance, and the minimum happens when this vector y minus xb is perpendicular to the column space of x, which means that y minus xb is orthogonal to every vector on the column space of x. So it's orthogonal to every vector of the columns of x, which means that the inner product, so each row of x transpose, which is the columns of x, each row of x transpose times the vector y minus xb should be 0. So that becomes, what we have here is x transpose times bracket of y minus xb should be 0. And we simplify that, we can get the b hat, which is the parameter we want to estimate as x transpose x inverse x transpose y. So here is why we want to prove x transpose x is invertible when the columns of x are independent. So this is why we prove the previous theorem. In order for this to be invertible, we can move the x transpose x to the other side of the equation. We need to know that x transpose x is invertible, and in most cases that's the case in regression analysis. So now because of that, we get the projected vector of y onto the column space of x is x times b hat, which is this equation here. So the projection matrix of x onto the vector onto the column space of x is this matrix. So x times x transpose x inverse times x transpose. And if x is a one-dimensional vector, let's say A, then this projection matrix is just A transpose A times a scalar value A transpose A. So that's it. That's all I want to talk about. It's basically a review of what is least square regression, least square method, and what is a projection matrix. Hope you like it. Please subscribe to the channel and like the button, smash the like button if you think this is useful. Thank you.